You are welcome to the Scholar School. We establish our footprints on the sand of time, experience the difference.
Good afternoon, everyone, and you're welcome to the Scholar Online class. I'm your tutor for today, Mr. Sam. So today we'll be looking at empirical and molecular formula. Now, empirical formula and molecular formula, it is used to get the true value of a particular compound. For example, if we say we have a compound like C6H6. Now, the purpose of empirical formula and molecular formula is to explain how we get this compound to be C6H6. So empirical formula expresses the components of a particular element or compound in the simplest whole ratio, in the simplest whole number ratio. So while molecular formula is the true value of a particular compound. Now we can calculate empirical formula and get something like this. Now this molecular formula will now express this value it will express this x, this unknown, to the true value. So when calculating for molecular formula, we need information from empirical formula to solve questions on molecular formula, or either we get information from empirical formula or we get information from the relative atomic mass of each of the compound and the vapor density or relative molecular mass. Now, to calculate for empirical formula, we need the mass of each of the elements, the mass of each of the elements, or the percentage of each of the elements in this compound. Now, if you are given a question to calculate the empirical formula of carbon and hydrogen. Now, to calculate empirical formula for this kind of element, we have to be given either the mass of carbon and mass of hydrogen, or we are given percent of carbon and percent of hydrogen. So it is with this percent or the mass that we are going to calculate the empirical formula. Now, after getting our empirical formula, let's assume we get our empirical formula to be CHX. To get the value of this X, we will now calculate with molecular formula. So molecular formula will now lead us to the true value of a particular compound. Now let's take a question to determine the empirical formula of some elements. Now we have a compound has the following compositions. A compound has the following compositions: 1.33 gram potassium, 1.33 gram potassium. That's the first. 1.77 gram chromium, 1.77 gram chromium, 1.77 gram chromium, and 1.90 gram oxygen, and 1.90 gram oxygen. Question says, calculate the empirical formula of the compound. Calculate the empirical formula of the compound. Now, we have been given what the gram of each of the combining elements. Now, these elements, they will combine to form a particular compound. Are we given the mass? Yes, we are given K. The mass K equals to 39. We are given chromium. Chromium is equal to what? 52. And our oxygen is equal to 16. Now, to calculate empirical formula of these elements, we have K, Cr, which is chromium, then oxygen. Now, the first thing is to write out the reacting mass. Here we have 1.33 gram. Here we have 1.77. And for oxygen, we have 1.90. Then the next thing is to divide by its mass number. Now, the mass number of potassium is what? 39, we divide this by 39. The mass number of chromium, 52, we divide this by 52. Then the mass number of oxygen, 16, we divide this by 16. 0.034, right? 0.034. For oxygen, 0.118. Now, after getting this, the next thing is to divide each of these value. You divide it by the smallest value. Now, here we have 0.034. We have 0.034, that's it. We have 0.118. So the smallest value here is what? 0.0034. So we divide both sides by what? 0.034. Divide all of the constituent elements by the smallest. So here we have 1, 0.118 divided by 0.034. 3.47. Now here we have 1. You can approximate this to what? To 3. So the empirical formula of this information is KCrO3. This is the empirical formula of this information. So simple and straightforward. From the reacting mass, these are the reacting mass: 1.33 gram of potassium, 1.77 gram of chromium, 1.90 gram of oxygen. Then you divide by what? By the relative molecular mass of each of the elements. Now for potassium, the molecular mass is what? 39. Now the molecular mass will be provided in the information given in the question. Now for chromium, 52, and for oxygen, 16. So after dividing, then you now what? Divide again by the smallest value from your answer. You divide by your smallest value, then you get what? Your ratio, 3.47. Then I approximate 3.47 to the simplest whole number. So we have 113. So this is our what? Empirical formula. Let's take a look at another question. So this question we are going to what? Calculate empirical formula and molecular formula. I said earlier that to calculate molecular formula, we calculate molecular formula from the information gotten from empirical formula or the atomic mass of each of the what? Of the various elements. Calculate the molecular formula of an organic compound containing 92.31% carbon. 7.69 hydrogen by mass if its relative molar mass is 78. Now to calculate, one thing I forgot to mention is that in calculating molecular formula, you will be given relative molar mass or vapor density. Relative molar mass, RMM, or vapor density. Now when you have your relative molar mass or you have your vapor density, if you are given vapor density, your vapor density, your RMM is equal to vapor density times 2. What I mean is that if in this question we were given RMM of 78, relative molar mass equal to 78. Now let's assume you were not given RMM, you were given vapor density. Let's assume you were given vapor density of 90. It means to get your RMM, it will be vapor density times 2, 90 times 2. So your RMM will now be what? 180. If you are given vapor density instead of RMM, you can't use your vapor density like direct. You have to multiply it by 2 because RMM is what? Is equal to vapor density times 2. Now in this question, we were given RMM to be 78. Now the first thing to do is to what? Calculate our empirical formula. Note, some questions will not ask you to calculate empirical formula. They will just give you that calculate the molecular formula after giving you the necessary information. But to calculate molecular formula, we have to first calculate the empirical formula. Now we write the reacting elements, carbon and hydrogen. The percent of carbon 92.13, for hydrogen 7.69. Then you divide each of the elements by their what? By their mass, by their relative mass, relative atomic mass, RAM, not RMM. Relative atomic mass. For carbon, it is what? 12. For hydrogen, 1. So 92.13 divided by 12 is what? For this, it is 7.69. 92.13 divided by 12. 7.67. So the lowest here, you divide by the lowest. The lowest here is what? 7.67. You divide by 7.67. Then here, 7.67. So we have 1 and we have 1.002, which is approximately 1. So which means our empirical formula now is what? So therefore, empirical formula EF equals to CH. Are you with me? Now to calculate for molecular formula, you will now say the CH is equal to your relative molecular mass, which is 78. Instead of writing X here, you can write N. Then you will add this up with their relative atomic mass. For carbon, C, that's 12, plus for hydrogen 1, that's 12 plus 1, equal to what? 78. 12 plus 1, that is 13. N equals to 78. Then you open your bracket, you have 13N equals to what? 78. Divide both sides by the coefficient of N, that is 13. We have N equals to 6. Our N is equal to 6. So we are not done. Now from here, it means that coming back to this, we have CH. Our N is now equal to 6. It means this is what? 6. If you multiply this 6 by what is inside the bracket, we have C6, H6. And some question, WAEC will go on to ask you that you should name the compound you get. Now this compound is known as what? As benzene. Now let's take this question. What is the molecular formula of cryolite? What is the molecular formula of cryolite? What is the molecular formula of cryolite? If it contains 32.85% sodium, 32.85% sodium, 12.85% aluminium, 12.85% aluminium, and the rest contains F by mass. F, that is fluorine. Now for this F, we are not giving the percentage. Let's continue. Full stop. The relative molar mass of the compound is 210. Relative molar mass is equal to 210. Open bracket. Na equal to 23. Al equal to 27. And F, our F is equal to 19. Now look at this question. We were given the percentage of what? Of sodium. We were given percentage of what? Aluminium. But we were not given percentage of what? Fluorine. Now, ordinarily, they expect us to what? Calculate the percentage of what? Of fluorine. And when we are talking about percentage, it means that for these three elements, the total percentage must be equal to what? 100. the total percentage of these elements must be equal to 100. So what we are going to do is to add up the first two percentage, then you minus it from 100 to get what? To get for fluorine. Now let's add this. We have 100 minus 32.85 plus 12.85. So we have 100 minus 45.70. So 100 minus 45.70, 54.3%. So which means our fluorine contains what? 54.3%. 54.3%. Now, having gotten this, the question asks us to calculate molecular formula, but first we have to what? Calculate empirical formula. So we calculate empirical formula first: sodium, aluminium, and fluorine. Now, the percentage of sodium 32.85, aluminium 12.85, then fluorine 54.3. Then you divide by what? By their relative atomic mass, which was given 23, aluminium 27, fluorine 19. Now 32.85 divided by 23, 1.4. For aluminium, 12.85 divided by 27 is 0.47. For fluorine, 54.3 divided by 19, 2.85. So the next thing is to divide by the what? By the smallest value here. So we divide everything by what? 0.47, because it is the smallest value. 0.47, 0.47. So here we have 1.4 divided by 0.47, 2.97. 2.85 divided by 0.47, 6.06. So from here we can approximate this. 2.97, we approximate to the nearest whole number, that is 3, 1, and what? 6. So which means our compound has sodium 3, aluminium 1, and fluorine 6. Now to calculate for molecular formula, you will now bring this information. That is why I said to calculate for molecular formula, we need information from empirical formula or a prepared formula to solve for molecular formula. Then you come to this side, Na3 AlF6 N equal to the relative molecular mass 210. So our sodium will now calculate the mass of each of the compound. We have 23 times 3 plus aluminium 27 plus fluorine 19 times 6 equals to what? 210. 23 times 3, that is 69, plus 27 plus 19 times 6, 114 equals to 210. Now from here we can say 69 plus 27 plus 114, 210 n equals to 210. So if you open the bracket, we have 210 n equals to 210. Our n is equal to what? 1. So now which means if our n is equal to 1 from here, Na3 AlF6, our n is equal to 1. So which means our molecular formula is Na3 AlF6. This is our molecular formula. See you in our next class. And if this is the first time joining us, please make sure you subscribe and click on the notification button so you can get our new video. Thank you.